Hello, welcome back. Today we are going to focus on the different types of solutions to linear systems of equations. Go ahead and take some time to fill in your table of contents. Still focusing on Unit 5, solving systems of linear equations. Our objective today is to determine the solutions of systems of equations and what are the three different types of solutions to systems of equations. So feel free to pause the video to write your heading down for today's topic. So solutions to systems of equations are very similar to the solutions to equations that we did back in Unit 2. So there's one solution, no solution, and infinitely many solutions. I've briefly talked about these with graphing, but now we're going to go into a little bit more detail. So using a graph, we need to make sure both equations are in slope-intercept form. So if you forgot how to switch this around, we need to solve for y. So that means we're going to put x on the other side by subtracting x. So we're going to get negative 3y equals negative x minus 9. And then we need to divide everything by that negative 3. So our first equation will become y equals a 1/3 x plus 3. The negatives are going to turn that positive. So that's our first line. So we're going to start by graphing 3 on my y-axis, and my slope is 1/3. So I'm going to go up 1 and over 3. And because this is a system, we want to make sure we are putting as many points on our graph as we can, so we can find that intersecting point. So now I need to focus on the next equation. So my next one is x minus y equals negative 1, and I need to subtract that x again. And then I'm going to divide everything by a negative 1. So y is going to be x, or 1x, plus 1. So I'm going to start at a positive 1, and my slope this time is up 1 over 1, and I continue until I find that intersecting coordinate. So in this case, when we have completely different equations, it will always be a one solution, and we can find that using a graph because it'll intersect at one point. So this would be a one solution, and then we need to say what that point is. So this is at 3, 4. One solution at 3, 4. Okay, when you are solving a system of equation algebraically, you're either using the substitution method or the elimination method. And now that you have learned it all, it'll be your choice on what you use. So when I look at these two equations, I'm going to use the elimination method because both my equations are already in standard form. So I need to make sure I get coefficients that are the same number but opposite signs. So I'm going to look for ones that are factors of the other. So I can see that 2 is a factor of 6. So I'm going to multiply that first equation by a negative 3 to get a negative 6. So I've got negative 6x minus 15y, and then negative 3 times 14. Again, if you don't know these off the top of your head, feel free to just type it in the calculator to check your answer, or just show a little work on the side. But 14 times 3 is 42, and that's going to be a negative 42 because it's a negative 3. So now I can eliminate my x's here. So I've got a negative 8y, because 7 plus negative 15 is negative 8. 10 plus negative 42 is a negative 32. I'm going to divide by negative 8 on both sides, so that gives me 4. So you can see as I'm solving this, I'm actually creating a coordinate. So this would be a 1 solution. I'm going to plug that back into the first equation because it's got some smaller numbers. So I'm going to get 2x plus 5 times 4 equals 14. 2x plus 20 equals 14. I'm going to subtract 20 on both sides. So that's going to give me a negative 6. So x equals negative 3. So again, this would be a 1 solution because I was able to solve for it, just like when we were solving equations back in Unit 2. And my answer would be negative 3, 4. Okay, so let's look at another one. Again, I've got my equations in standard form. I need to switch them around to slope-intercept form. So I'm going to look at x minus y equals negative 4. I need to subtract x on both sides. So I've got negative y equals negative x minus 4. And then I need to divide by a negative 1. So my first equation becomes y equals 1x plus 4. Let's go ahead and just do the next equation. So I'm going to add 3x on both sides. So I'm going to get 3y equals 3x minus 6. And then I need to divide every term by 3. So you'll see now I've got 2 equations. What I really want you to notice is the coefficient or our slope in front of x. Watch what happens when I graph these. So for the first one, I'm going to start at a positive 4. And my slope is 1 over 1. So I'm going to go up 1 and over 1, down 1 and over 1, and I'm going to draw those points all the way across the graph. Now I'm going to graph my second one. So this time I'm starting at a negative 2. My slope's the same. So I'm going up 1 and over 1, down 1 and over 1. So you can see here, these lines do not cross, they are parallel. When our slopes are the same, when we have a parallel lines, this is a no solution. Okay, so when they do not intersect, that's a no solution, and we should be able to tell because our slopes will be the exact same. Another way we could tell is we could create an equivalent equation. So if I came up here and I divided everything by 3, because that's a common factor here, this equation would turn into negative x plus y equals a negative 2. And you can kind of see that we've got some similarities going on between the first one and the second one. But we really can't see that until we switch it into slope-intercept form and we can tell that our slopes are exactly the same. And then notice we'll also have different y-intercepts. Let's take a look at what that would look like if we have equations in standard form and we're using algebra to solve for that. So what we can see here is I've already got opposite signs and coefficients. So I'm going to use elimination again because they're in standard form, and that's just easier than trying to use substitution. And what we can see is that our coefficients in front of x are a positive 1 and a negative 1, so those will eliminate. And our coefficients in front of y are a negative 2 and a positive 2, so that's also going to eliminate. So we are going to end up with 0 on this side. And then on the other side, we have 14. So much like when we were solving equations, if we get a false statement, meaning that 0 does not equal 14 or 0 equals any type of number, so it's a false statement, this is a no solution. The reason being is because these two lines are parallel. They're not going to cross on the graph. Okay, so let's take a look at another example and see what happens here. So my first equation is x plus 3y equals 6. I want to turn it into slope-intercept form. So I'm going to subtract x on both sides. So I've got 3y equals negative x plus 6. And now I'm going to divide every term by 3. So I equals a negative 1/3 x plus 2. Now I'm going to look at that next line here. So I'm going to add 2x on both sides. So I've got negative 6y equals 2x minus 12. And then I need to divide every term by a negative 6. 6 is going to reduce to 1/3. So I'm going to get a negative 1/3 there. And negative 12 divided by negative 6 is a positive 2. So go ahead and take a minute to look at what we see here. You should recognize that these are the exact same lines. So when I graph them, I'm going to start at positive 2, and I'm going to go down 1 and over 3. And I'm going to do it in the exact same opposite direction, so up 1 and to the left 3. And we can see there's my first line. And now when I graph the next line, I'm doing the exact same thing. I'm starting at 2, down 1 and over 3, and up 1 and over 3. And what happens is every single point matches. We get a line on top of a line. Just like when we were solving equations, if both sides of the equations are exactly the same, it's infinitely many solutions. So here, both equations are exactly the same, so this is infinitely many solutions. Okay, well, let's see what that will look like if we're using our algebraic method. So here I'm going to use substitution, the substitution method, because I have an equation in slope-intercept form. So all of this is going to go into for y. So I'm going to have negative 16x plus 2, and I want to use parentheses to substitute that in there, equals negative 2. So I need to distribute, so negative 16x plus 16x minus 2 equals negative 2. Well, we should recognize right now we're just solving an equation, a multi-step equation. I combine these like terms. Negative 16 plus 16 gives me 0. They cancel. So I'm really left with negative 2 equals 2. And we've learned that when we have a true statement, that this is infinitely many solutions. Let's just take a look at a couple more examples. So here we should recognize that we can eliminate both the x and the y. Same coefficient but opposite sign, so I'm going to get 0 over here. 5 plus negative 9 is a negative 4. This is false. False statement. 0 does not equal negative 4, so this would be a no solution. Remember, that means that it's parallel on the graph. Okay, last one here. Here we should recognize that both 6 and 7, same coefficient, opposite sign, so they eliminate. And on the other side, I'm going to get negative 4 plus 4, that's also 0. So this here is true. 0 equals 0. So this would be infinitely many solutions. Remember, if you had any questions, make sure you write them down to ask me during class the next day.